8 planets, billions of kilometers apart, each one operating by completely different rules. Let us start with our very first planet, Mercury. Mercury is the closest planet to the Sun and also the smallest planet in the solar system. Despite being so close to the Sun, it is not the hottest planet, a fact that surprises most people. Because it has almost no atmosphere, it cannot trap heat. The side facing the Sun reaches temperatures of around 430 degrees Celsius, while the side facing away can drop to -180. Mercury completes one full trip around the Sun in just 88 Earth days, making its year remarkably short. Its surface is covered in craters, scars left behind from fragments of years of asteroid impacts, and it has barely changed since the early days of the solar system. Now let us move to our next planet, Venus. Venus is the second planet from the Sun and the hottest planet in the solar system. Despite not being the closest, its thick atmosphere is made almost entirely of carbon dioxide, trapping so much heat that the surface sits at around 465 degrees Celsius all the time, day and night. The atmospheric pressure on Venus is about 90 times greater than on Earth, which would crush most human-made machines almost instantly. Venus rotates in the opposite direction to most planets, meaning the Sun rises in the west and sets in the east. It also rotates extremely slowly, so a single day on Venus is longer than its entire year. Next up is the third planet, Earth. Earth is the third planet from the Sun and the only planet confirmed to support life. It sits in what scientists call the habitable zone, a range of distances from a star where liquid water can exist on the surface. About 71% of Earth's surface is covered in water, and its atmosphere is a carefully balanced mix of nitrogen, oxygen, and other gases that shields life from harmful radiation. Earth has one natural satellite, the Moon, which stabilizes its tilt and plays a major role in ocean tides. Of all the planets discovered so far, none have been found to match the combination of conditions that make Earth suitable for life. Let us now look at the red planet, Mars. Mars is the fourth planet from the Sun and has been studied more closely than any other planet beyond Earth. Its reddish color comes from iron oxide, essentially rust, covering much of its surface. Mars has the tallest volcano in the solar system, Olympus Mons, which stands nearly 3 times the height of Mount Everest. It also has a canyon system, Valles Marineris, that stretches as wide as the United States. Mars once had liquid water flowing across its surface, and scientists believe it may have supported microbial life billions of years ago. Today its atmosphere is thin, cold, and mostly carbon dioxide, but it remains the most realistic target for future human exploration. Now we move to the giants of our solar system, starting with Jupiter. Jupiter is the 5th planet from the Sun, and by far the largest planet in the solar system. It is so large that all other planets could fit inside it with room to spare. Jupiter is a gas giant, meaning it has no solid surface. It is made almost entirely of hydrogen and helium, and the deeper you go, the more compressed and hot those gases become. Its most recognizable feature is the Great Red Spot, a storm that has been raging for at least 350 years and is wider than Earth itself. Jupiter also has a powerful magnetic field and at least 95 known moons, including Europa, which is thought to have a liquid ocean beneath its icy surface. Next is perhaps the most beautiful planet in the solar system, Saturn. Saturn is the 6th planet from the Sun and the most visually distinctive planet in the solar system. Its rings are made of billions of pieces of ice and rock, ranging from tiny grains to chunks as large as houses. Despite how solid they look from a distance, the rings are remarkably thin, in some places only about 10 meters thick. Saturn is a gas giant like Jupiter, and it is the least dense planet in the solar system, light enough that it would theoretically float on water. It has 146 known moons, more than any other planet. Its largest moon, Titan, has a thick atmosphere and lakes of liquid methane on its surface, making it one of the most unusual worlds in the solar system. Let us now head to the ice giants, starting with Uranus. Uranus is the 7th planet from the Sun and belongs to a category known as ice giants. Unlike Jupiter and Saturn, it is made largely of water, methane, and ammonia, in icy forms beneath its outer layer of hydrogen and helium. One of its most unusual characteristics is its extreme axial tilt. Uranus rotates on its side, with its poles pointing roughly toward and away from the Sun as it orbits. This means each pole experiences around 42 years of continuous sunlight, followed by 42 years of darkness. Uranus also has rings, though they are much darker and harder to see than Saturn's. And finally, we reach the farthest planet in our solar system, Neptune. Neptune is the 8th and farthest planet from the Sun in the solar system. It is another ice giant, similar in composition to Uranus, but distinctly more active in terms of weather. Neptune has the strongest winds ever recorded on any planet, reaching speeds of up to 2,100 kilometers per hour. Despite being so far from the Sun, it radiates more heat than it receives, suggesting it generates its own internal warmth. Its deep blue color comes from methane in the atmosphere absorbing red light and reflecting blue. Neptune has 16 known moons, the largest of which is Triton, an unusual moon that orbits in the opposite direction to the planet's rotation, leading scientists to believe it was captured from elsewhere in the solar system, rather than formed alongside it.